Hi all, good evening. Sorry, I started a wrong meeting. I started a different meeting and was waiting for you people. And I didn't know no one was joining the meeting. I got a doubt and I checked that meeting link. I found that I started a different meeting. Okay, yeah, good evening, very good evening.
Good evening.
Yeah, okay, good evening all of you. So, welcome back. Now back to the basics.
Good evening, sir. Merry Christmas.
Thank you, wish you the same. Thank you, Merry Christmas all of you. Yes, still it is, yeah, interest for you people. Yeah. Merry Christmas. I hope you enjoyed it. Yes, it will be very fun for there in this. Yeah, okay. So let's start. Where did we stop in the last class? We were talking about querying, and I've asked you people to write join queries. I guess that is where we stopped. Yes. So we saw how to write a HQL query, HQL join query, right? Yeah. So first of all, so let's start with outer join. See, when we talk about joins, so there are two different types of joins. So what are the two different types of joins? Yes, let's see. Number one is, okay,
Inner joins and outer joins.
yeah, left outer join. I'm talking about outer joins. Yeah, left outer join and right outer join. Left and right outer joins are there. Yes. See, what is this left outer join? What do people think? Yes, left outer join.
It matches the left side of the um, Sorry.
Returns all rows from left table and common rows from both the tables. That's right, exactly. So by default, it will return the records, all the records from the table which is on the left side of the join. By default, it will return all the records from the table which is on the left side of the join. And from the right side, only the common tables will be fetched here. That's it. Yeah. So that is how it works. You know what? This query is very much similar to that inner join query which we written. Just we need to change that outer join clause, sorry, inner join clause to outer join, left outer join. That's it. Let me open the schema. Oh, here, okay, you have this join query, inner join which are written here in the last class. You see, I'll change this inner join clause to outer join, left outer join. That's it. The remaining query remains the same. That inner join query, it remains the same here. Okay. Yes. So let's run this query. Okay. So you can keenly observe this query. You'll find it. See, here you got 74 records. Actually, in the product table, you have 74 records. You got all the 74 records here. But how about the supplier? You see, on the left side of the join, see on the left side of this join clause, left of the join, we have product table. So all the product records will be fetched. On the right side of the join, you have the supplier. Only the associated records from the supplier. If there is an associated product for the supplier, only if there is a product associated to the supplier, okay, if it is mapped to any supplier, to any product, only that product will be fetched here. That's it. Yeah. If there is an associated product for the supplier, then only this records will be fetched here. That's it. Okay, fine. If you scroll down, you see, you'll find that for most of the products, there are no suppliers associated. Even though there are no associated suppliers, this record will be fetched here. That is what happens. So that is left outer join actually. Yes. Okay. Now, how do we write this query in HQL? So we saw this query in SQL. Let's try to write it in HQL. We'll write it in the similar way almost. There won't be much difference. See, left outer join. Yes. Check this query. No, but there will be one problem while reading the records. What is it? See, not all products are associated with the suppliers, right? Few suppliers, sorry, few products have got no suppliers. For some products, there are no suppliers. So what you will do with those products here? I mean, the supplier reference will be null for some products because there is no supplier associated to it, right? So you may end up with null pointer exception. So while reading, you have to be careful. You may get null pointer exception. Okay. So look for the supplier references. If they are null, check for null references here in case of suppliers. Yes. There is one thing which you need to consider here in case of outer join. So I'll run this code. I'm not checking for null references. It should throw error. See, we got null pointer exception. You see, when reading supply details of a particular product. For that product whose ID is 0, there is no supplier. So the reference will be null for that particular product. Yes. So it throws this exception. So make sure that while reading the supply references, it is not null. If they are null, don't read the supply reference. Okay. Mm, if supplier not equal to null, then only use that reference. Okay. Now you won't get that exception. That's it. Now, quite opposite to left outer join, you got this right outer join. You know that, right? Yeah. So you can write a right outer join here in SQL. So what will be the difference here in that case is So in case of right outer join, what happens? You see, all the records from the table which is on the right side of the join will be fetched, and only the records which have got an associated record will be fetched from the table which is on the left side of the join. Yes, only the common records will be fetched from the table which is on the right side of the, sorry, from the left side of the join, you can say. From the table which is on the left side of the join, only associated records will be fetched here. Yes. Okay. So in our example, we consider this example from the table which is on the right side of the join, all the suppliers will be fetched. What about the table on the left side of the join? We have product associated here. Sorry, we have product table on the right, on the left side of the join. Only the products with associated suppliers will be fetched from the product table, which is on the left side of the join. You can say. Yes. Okay. So this time, let's see how many records you'll get. You got only 13 records. Okay, you got 13 records here. That's it. You see, is there any supplier which has got no product associated to it? Yes, we do have a supplier without any product. There's no product associated with it. Yes. Yeah. So you see, that means the product for this supplier, there won't be any product, right? It will be null reference. Okay. There won't be any product object associated to the supplier. So product reference will be null for this product. Yeah. So you have to check for null reference. If product not equal to null, then only will work with it. Yes. Yep. Okay. So change this query from left to right. You can try running this query. See, you got the record. See. So this is about joins. Okay. Any questions in this regard? Okay, you know what? Here we got an option to write a named query here. Yes, you can write a named query. So what is this named query actually? Named query. Yes. Have you people heard about it? Yeah. Let's see how it looks like. You know what we did here? I've written a query. I can say I've configured a query here. So where is the query configured? You see, on top of that entity class, we have created a query. We have written a query. I can say we have written a query, and a name is given to this query. You see, we're giving a name to this query. I can say what is the name of the query? My query. The name of the query is my query. What is this query all about? It fetches all the records from the product table. That is the query here which you got. It fetches all the records from the product table. That is the query which you got here, right? Yes, fine. So where to execute this query? We can execute it using query interface again, the way we did it earlier. Only thing is we need to access this query. How to access this query? Using the name, right? So this query has got a name. So use that name to access this query. Yes, my query is the name of that query. Yes. Let's write this. Just a minute. Test name query. You see, we got a method called as create named query. If you want to create a named query, you need to use this method, I can say. So you see, this method, it will take the name of the query as input. You have to pass the name of the query as input here to this method. So just now we gave a name to this query, right? What is it? My query. You can just use that name here, name my query, and then you see this method, what it does, it returns a query object, and straight away you'll get a query object here. And here you have to specify in this query when it is executed, you'll get what type of objects. Yes. Sorry. How to execute this query? It's a HQL query itself. How will you execute this query?
List.
List. Yes. You need to call list method, execute this query. You'll get list of product objects. Yeah. So I'll close the session. Close the session. Okay. Yep. Okay. So what is the advantage of writing the name query? Yes. Now you understood how to write a name query, right? So what is the advantage here? Yes. Now you saw this name query, right? Yes. What do you think? So what is the advantage? No idea. I can say that this query is reusable. The query is actually reusable. Reusable in the sense, you see, here throughout the application, wherever you want to execute this query, simply now you can use the name of this query. You don't have to write this query again and again, right? Once you have written the query, you can simply make use of it. Yes. Okay, good. So I hope you people got it. So let's move on. Now next, I'll talk about inheritance mappings. But before that, I have one small thing here, that is element collections. Let's see. So all of you look at this requirement. You have category, right? You have a category ID name, and then in our requirements, you saw that here. So users should be able to browse through these categories, right? Yes. How the users should be able to browse through those categories. See, they want to search some categories. So how they can do that? Yes. I mean, see, the application is supposed to provide some search keywords for it, right? Application is supposed to provide some search keywords, right? So for this category, I would like to add some search categories here. For this category, I would like to add some search search words. I can say, sorry, search words, searching words. So whenever uses the search words to search for the category, then this particular category should be displayed. Generally, we do that, right? So you might have definitely did this. Might have searched for few categories while browsing through that online shop, right? So the search keywords will be there. Search keywords is a collection here, which is of type string. And I can say we'll have some keywords. So whenever user is searching for that category using these keywords, so this keywords are associated with this category. Whenever user searches the category using these keywords which are associated with this category, then the application is supposed to display this categories here. Yes. Now the question is, how will you store the keywords associated with this category? That's the question. Storing the keywords associated with that category. What you will do? Can you people tell me? Let's say this is what I have on the Java side. How will you create the table here? Yes. And how will you store the data related to this? Related to this category. Yes. Okay. First, you got the question right, all of you. Yes, all of you. Is the question clear for you people? I need a table on the database side. which can be used to store this category as well as the keywords associated with this category. So what you'll do, what you'll do. What is special about this? It is slightly different here, especially the keywords. Okay, um, how to store the keywords associated to a particular category in the table. Okay, come on, I'm waiting for you people. Give me a suggestion. So, can we store that keywords associated to the category within the same table, category table? Can we do that? Yes. You see, we cannot store this category names, sorry, search keyword names in the table, category table. It is not possible. You know that? It is not possible. Not at all. We can't do that. Okay. In a row, you see, for a category, you'll have only one row in the table. If you want to store the search keywords, there will be only one column to store the search keywords. In a column or a cell, in a particular cell associated to a column, you can store how many values? Only one. You can't store multiple values over there. It is definitely not possible, right? So it won't be possible. Yeah. So what to do in this case?
We'll have a separate table where we store these keywords, and we can store the keywords of multiple tables in one single table.
Okay. So that's right. You see, we need to create a separate table. Okay. We need to create a separate table here, definitely. And the table, you'll find that here. Will only hold the keywords, just keywords. We'll only have keywords here. Yes. Just you see, these keywords are just simple values, right? So we can't say it is actually a separate entity. Unlike the associations which we saw so far, it's not an entity. These are just set of values. So whenever you have this requirement, you see, yes, you will create a separate table now. You will create two tables. One table for category, where you will have this category ID and all. And there is another table called as keywords table, let's say. In the keywords table, you'll have this keyword, and you'll have a column, a foreign key column, which refers to the primary key of the category table. That that's it. So this is a special mapping now. Yeah. So let's see what to do on the Java side, especially the mapping I'm talking about. Yeah, you can check this. This is the property which I'm talking about. The keywords, the set type collection now. Keywords is a set type collection, and you see, we are specifying that table details. What is the table name? The table name is, you see, using this table collection. You see, because the table, it holds that collection set of values, right? Collection values here. This is called as a collection table. And you see, we are specifying the table name. So what is the table name? So the table name is keywords, and you see, in the table we have a foreign key column, right? Join columns. What is the foreign key column? That category ID will be there, which refers to the primary key of the category table, as I told you. On top of this table again, we are adding this column annotation to specify that values, you see, will be stored into which column. That category keywords, that keywords, I'm sorry. The keywords will be stored into which column in the table collection table. We have a column called as keywords. That's it. So actually we call it as element collections. You see, on top of this property, keywords, the name element collection is used. Yes, element collection. Yes. Okay. So this is how, if you have a set of values associated to an entity, you see, you can store that set of values into a table. And the table is called as element collection. The table is actually called as element collection. That's right. And this is how we'll provide that mapping details and all. Collection table, keywords, the foreign key column details, and the column name where this value will be stored in that table. Yes, collection table. Okay. Can you people give me one more example for this type of requirement that you may come across element collections? Yes, element collection, for element collection. No, come on here. You may find some examples. Think about it.
Amazon.
Amazon. Okay.
So if you're searching for some product or category, it will give you various options.
Yeah. Okay. I want you to give me some other example for this element collections. Already we saw the such categories, right? Mm, any other example?
In Google also, if you search something related item, it will come.
Okay. Mm, another example for element collection. I'll tell you.
Like
Yeah, tell me.
if I have a product, if I have a single product called iPhone, there are different variants like iPhone 5, iPhone 6, and iPhone 7. So I think in that case we might use this element collection.
No, there'll be separate objects itself. There'll be separate objects. Entities. iPhone is a separate object itself. Yeah. I'll give you. It is phone, na? On the phone itself, I'll tell you. So in the online shop, if you people have noticed it, you will find that uh, you can browse through the items in the online shop, right? You'll be browsing through the items. Here, the thing is, for an item, you may have several images. For an item, there can be several images, I can say, right? So to view the item in different angles, in order to view the item in different angles from different sides, you may have several pictures for that item, right? So I can say here for item, you have set of pictures. Basically, you'll have that file names. So what are all the names of those pictures? So they might be stored on the file system somewhere. So what are all the picture names associated with this item? Okay, the picture names associated to this item. You'll find that here you, you'll use this element collection. Yes. For an item, you may have 5, 10 images, 10 pictures. So the names of those pictures of file names, I can say. Picture names means the file names itself. I'm referring to the file names here. Okay. Yes. So what you'll do in this case, how many tables you'll create? you'll create two tables. In one table, you'll have the item details, entire item details. So in another table, you'll store only that images here. That's it. Image names. Okay, the picture names or image names will be there in the other table. That's it. You'll have two tables. One for storing item details, and the other one for storing image names. That's it. So I hope you people got it. So element collections are also very useful. You see, you have this common requirement, I can say. Next, have you noticed it? There is another special association here. What is it? Category. If you take our example, electronics, let's say is a category. Under the electronics, we have mobiles category, let's say. Mobiles got a category called a Samsung, Apple, BlackBerry, and so on. So you see, Samsung is a subcategory of mobiles. In turn, mobiles is a subcategory of electronics. You see, Samsung is just a subcategory. For the Samsung, there is no parent category, right? For Samsung, we don't have any subcategory here. It is a subcategory of mobiles. Mobile has got a subcategory, not one. You have several subcategories, three. And again, in turn, mobile is also a subcategory of electronics. So a category is a parent category and it can be a subcategory also at the same time, right? Yes, here is the example. So how will you store these details here? What you'll do? How will you map this or store this information here? Yes. On the Java side, how will you represent this association? For a category, you got a parent category here, right? And a subcategory. So not inheritance. So if you can check this here, this is the category class. Have you noticed it? We have a reference to the category, self-reference. Category has got a reference to itself. Category holds the reference to itself here. Category object will hold the reference to itself. This is self-reference. Why? You know the reason, right? Yes. Because a category can have a parent category which is also in turn a category itself. Parent category is also a category object itself, right? Yeah. So on the database side, you will have a column. On the database side, you will have a column called as parent ID, which will be referring to the primary key of this category table itself, self-reference. We say this is actually self-reference. Yes. Okay. You will find that, you see, this table, it will have a reference to itself. Self-reference, we say. Yes. Okay. Yes. Parent ID. I hope you got it. Category. Let's say if there is no parent ID for this particular category, then what it means? If there is no parent ID for this category, then what it means? Yes. If there is no parent ID for this category, for this row, for a particular row category, there is no parent. That means, yeah, it's a main category which has got no parent categories here. For this category, there are no parent categories. For this category, there are no parent categories. So that is what it indicates. If there is a parent ID here associated to this category, then we can say, yes, of course, you got a, parent for this category, and this category is a subcategory. That is what it indicates. Yeah, self-references, right? So can you people give me another example for this? Yes. So the entity object has got the reference to itself. The entity object here, that's got a reference to itself. Self-referencing. Okay, fine. I want you people to just get at least one or two examples for this type of associations. Okay. Fine. Self-references. I'll do one thing. I'm feeling a little uneasy today, so I'll stop it here today. So let's meet tomorrow and we'll continue our discussion, okay? So tomorrow I will show you inheritance mappings. We'll see how to work with this inheritance. Okay? We have various strategies provided by Hibernate framework. We'll work on it. I'll stop it early. Sorry. So tomorrow we have the class at our regular time. Meanwhile, you people try to work with that schema. I gave you the sample schema. I'm not sure how many of you have started identifying that associations between the tables in the schema, classic schema. Try to work with it, okay? So did I give you the link? You got the link for the schema?
I think we didn't get, sir.
Oh, sorry, this 2 days just off. I didn't touch my machine at all. Just a minute. Let's copy it somewhere. You can copy, all of you just copy this link. Sorry, copy the second one. Second.
Sir, what is the best book for Hibernate? Like,
Hibernate in action is there.
okay. Thank you, sir.
You're welcome. I hope you people have copied it. Yeah. Okay then. Thank you. Bye bye. Let's meet tomorrow.